Assalamualaikum and hi. My name is FARIS bin Mat NAZARI, metric number B0819104008. Today, my team and I will be present about the project of electronic system BEEE2354, semester 2, year 2. Okay, let's go. For the introduction, based on the assignment we have given by our lecturer, we already performed a group to do the assignment about the electronic system based on the block diagram given. The electronic system consists of two wind bridge oscillator circuit, active low pass filter, full bridge rectifier circuit, voltage regulator, and load. A wind bridge oscillator used to RC network connect together to produce a Snyder's oscillator. The circuit is based on the frequency selective form of the Winston bridge circuit. A low pass filter is a filter which pass all frequency from DC upper cut off frequency and reject any signal above this frequency. A full wave rectifier is a circuit arrangement which make use both half cycle of input alternating current AC and convert them to direct current DC. Thus, a full wave rectifier is a much more efficient than a half wave rectifier. This process of converting both half cycle of the input signal AC to direct current DC is a term full wave rectification. A voltage regulator is designed to automatically regulate voltage level. It basically step down the input voltage to desired level and keeps that in the same level during the supply. This can make sure that even when load is applied, the voltage doesn't drop. Okay, for the first one, for the result of oscillator 1, oscillator type is a wind bridge oscillator. Resonant frequency is 1 kHz. DC supply VCC is a 15 volt. Okay, for the negative feedback loop, using formula AV is a 3, AV1 plus RF divided by R1, and the 2 equal to RF divided by R1, and RF is a 2 R1. 3 equal to 1 plus RF divided by R1. Let's R1 is equal to 10 kilo ohm. RF will be equal to 3 minus 1 multiplied by 10k equal this 20k, and the approximate with 22 kilo ohm. For positive feedback loop, using equal value of R and C, we can select C is 1 nanofarad and calculate the requirement value of using of R. Using FR is 1 kHz is equal to 1 divided by 2 nRC. R is equal 1 divided by NNFC. Then R is 1 divided by 2n multiplied by 1k and multiplied with 1n, and we get 159.15 kilo ohm and approximate with 158. This is the circuit design. Okay, let me show you the real one. Okay, this is a circuit. Then after we run this, we get the output. This is the output. We get the max is a 14 volt. Channel 1 for frequency is 984 Hz, and for the peak to peak is 28.2 volt. This is the output. It's same. Actually, it's the same one. Then the oscillator 2 will be presented by another member. That's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Zahir and my metric number is B0819101177. So I will present for oscillator 2. This is the calculation for the negative feedback loop. AV equal 3, 1 plus R2 over R1 over R2 equal to 3. We transfer 1 to the opposite side, so that R1 over R2 equal to 2. R1 equal to R2. Then we take that R2 is equal to 20 kilo ohm. Therefore, R1 is equal 40 kilo ohm. For the positive feedback loop, using the value of R and C, we can select C is equal to 0.22 microfarad and calculate the unique value of resistance using FR equal to 1 over 2 pi RC. 1 over 2 pi RC is equal to 3 kHz. Therefore, FR is equal 1 over 2 pi, then the C is 0.22 micro and the R is 20 kilo ohm. So the resistor is equal 36.17 ohm. We can expect that it will equal to 36 ohm. So this is the my graph. This is my simulation. This is for the negative and this is the positive. So we will get the output like this. The frequency is 6.6 kilohertz. Peak to peak is 9.49 volt and the max is 4.73. That's all from me. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh, and good day to those who watching. My name is Ezzat Syahmy, and I will explain the active low pass filter part of this project. So the low pass filter is given a specification which is it has to be second order and Butterworth response, and for the cutoff frequency is 8 kilohertz. So this is the calculation. We would assume the RA to be 586 ohm. So based on that calculation, the RA I will get 586 ohm and RB I will get 1 kilo ohm. And after we get the RA and RB, we assume the resistor for this one will be 1 kilo ohm and also 1 kilo ohm. And from that we will get from the calculation above, we will get the capacitor 1 and 2 to be 10 nanofarad. So this is the actual low pass filter circuit design. And by using this board plotter, I can detect the slope, and with using calculation I will get a negative 40 dB per decade.
My name is Muhammad bin ALHAM. I will present number 4, which is rectifier. So I will start with the calculation of the circuit, which is VDC equal to 2 VP divided by pi. So 2 VP we get from the circuit, which is 20 volt. We divide it by pi and we will get 12.70.2. So for the VP, V out is V in minus with 1.4 volt, which is the diode of the circuit. So we get 20 minus 1.4. So for the ripple, so for the ripple, we use the calculation of ampere divided by 2F times C, which is 2.2.72 divided by 2 times 30 times 220 micro, which is we get 1.721 volt. So we go to the circuit. As you can see, the circuit here and here. So we go to the result of the multimeter. So we need to run this and then open up the multimeter platform, just like this. We get it from here. For the X3, we need to use ampere. For the X1, we use volt. Alright. And for the the resistor, we also get 9.34 as the circuit in the result. So for the oscilloscope, we just open up the Tetronic oscilloscope like this, and then we go ahead and setting it a bit. Alright. So this is the result of oscilloscope as the answer on words. So we'll go to the next one, which is oscilloscope, the other oscilloscope, which doesn't use the Tetronic oscilloscope. So this is the result of the oscilloscope. Okay, that's all from me. Thank you.
Assalamualaikum and hi, my name is ZIKRI MARZUKI. My meeting number is B0819104443. I am from BET S2/1. So I'm gonna explain about my part in this project, which is voltage regulator. So this circuit, it has output voltage is equal to 5 volt. So the voltage regulator type is op-amp shunt regulator circuit. So when it comes to calculation, so VL is equal to 5 volt and IS equal to 0.8 ampere. So this is the formula for how to get the VZ. So VZ is equal to VL minus VBT, which is 5 volt minus 0.7 volt equal to 4.3 volt. So IL, assume RL is equal to 100 ohm. So this is the formula for IL, which is IL equal to VL over RL. So it equal to 5 over 100. So we get 0.05 ampere. So RS assume V input is equal to 15 volt. So IS is equal to V input minus VZ over IS. So we get RS is equal to V input minus VZ equal over IS. So equal to 15 volt minus 5 volt over 0.8, and then we get 12.25 ohm. So this is the formula for IC, which is IS minus IL equal to 0.8 minus 0.05 is equal to 0.75 ampere. So when it comes to circuits, this is the circuit. So this is the raw circuit without any multimeter to measure the value. So we got V1 here 15 volt, we got R1 12.5 ohm, then we got diode, we got the transistor. Okay, then we got the op-amp, sorry. So we got four multimeter to measure the value. So for the first multimeter, we got 777.81 milliampere, and for the second multimeter, we got 769.244 milliampere. So next we go to third multimeter, we got 1.2 ampere, and we go to the last multimeter, we got the same value as third multimeter. So that's it for voltage regulator. Then we go to load. So the load is the same circuit, but we just measure it at the load only, the R2 only. So the load rated power is equal to 1 watt. So P load is equal to 1 watt. P load formula is V load over R load. So we get V load is 5 volt and R load is 5 squared equal to 25 ohm. So as you can see here, V1 still 15 volt, then we got R1, then we got still the same component, but we have only one multimeter attached parallel to the load R2, which is 25 ohm. So we got the value 5.211 volt, and then for the second output, we attach, I measured it in uh, what we call this series. We go series. For the first one we parallel and then we go series. So the value is 208.429 milliampere. So that's all for the circuit. So from the discussion, for the circuit that we designed, the oscillator produces a periodic electrical signal in sine wave to convert DC signal to AC signal. Voltage summing amplifier is used to combine the output signal from the oscillator. Then we use active low pass filter to alter the frequency response of the filter circuit by producing more selective output response, making the output bandwidth of the filter narrower or even wider. After that, we use the voltage rectifier to convert the alternating current, which is AC, to direct current, which is DC, which is required to the DC operated system. Then output signal from when to basic shunt voltage regulator to provide regulation by shunting current way from the load to regulate the output voltage. So for conclusion, at the end for this project, we managed to complete the project successfully. We also able to run the circuit and get correct and precise data. The data that we get are near to our calculation value, so that we assume that we managed to get the correct data and the correct circuit lah. Next, there is problem that we faced. We realized that we have problem when it comes to combining the circuit for the project. After having some discussion with our team, we managed to overcome the problem and come out with a complete project and correct data. That's all. Thank you.